Okay, pre-cal, we're going to talk about properties of logs. We've already done this in class, but I just wanted you to have a video. So if you'll notice, I've got the expanded side here. These are expanded into multiple terms or with the power moved down here. And then over here on the right, we have our condensed versions. Okay, so in our examples, if we're going to expand, we have one term here and we want to expand it so that we're using these properties to create multiple terms. So we've got 12 times x to the fifth times y to the negative 2. So if this is being multiplied, like this mn here, that means we are going to create an expansion of addition. So I'm going to have log of 12 plus log of x to the fifth plus log of negative 2, y to the negative 2. All right, now I'm going to use the power property to move from the condensed form to the expanded form by moving the exponent down into the front of the term. So I've got log 12 plus 5 log of x minus 2 log of y. And that's all we're doing. We're not going to solve right now. We are learning how to do this so that we can use it for solving, but we're not solving right now. These don't have any equal signs. Okay, so I'm going to look at number 2 here. I have natural log of x squared over the square root of 4x plus 1. So obviously this is division here in the condensed form, and I need to use subtraction to expand it. So that is going to change to natural log x squared minus natural log square root of 4x plus 1. Now when we take the square root of something, it's the same thing as writing 4x plus 1 to the 1/2. So now we're going to use the power property on both of these. So that gives me 2 natural log x minus 1/2 natural log 4x plus 1. So that's what the expanded version looks like. Okay, now I'm going to erase what I drew here, and we are going to switch our marker color. So now we're going to look at what condensed would look like. So now we're going from this side over to this side. So notice that on 3 and 4, I've got, on 3, I've got 3 terms, and they're being added and subtracted. And then I've got 2 terms on 4. So I'm going to condense these down into one term, one single term. So the first thing I'm going to do is I'm going to take care of these numbers in the front and put them back in the exponent position, just like the power property shows. So I've got log base 2 of x plus log base 2 of y to the fifth. Now at this point you can do plus log base 2 of z to the negative 6. You don't have to do it that way. You could have done it this way. You could have written log base 2 of x plus log base 2 of y to the fifth minus log base 2 of z to the positive 6. It really doesn't matter how you do it. You're still going to end up with something that's equivalent. So now I'm going to use my product property here and my division or quotient property here. So I've got log base 2 of x times y to the fifth divided by z to the sixth. And that is directly following from this step here. But if we had stuck with using this one up here, we'd have log base 2 of x times y to the fifth times z to the negative 6. And if you'll recall, z to the negative 6 can be written as 1 over z to the 6th, which would have been exactly what that looks like. So you get two things that are equivalent. This can be your answer right down here, or this can be your answer. They're both correct. All right. So now let's look at example 4. Again, we have numbers down in the front, so I'm going to use my power property to rewrite this as natural log x to the 7th plus natural log y squared. And then I'm going to use my product property since I've got addition here. So I've got natural log x to the 7th y squared. And yes, it is just that easy. In the next video, we will solve some log equations using our properties.